Every moonshot project starts with a dream. My dream is to bring to the world the most sustainable biofuel for this generation and many generations to come. We believe ButyFix is our answer to pursuing the goal of more eco-friendly transportation.
Hello everyone, I'm Julie.
I'm Mel. We are here to introduce you a novel bio-butanol production technology, ButyFix, which can help reduce CO2 emissions.
Fighting against climate change is an act now or regret later issue everyone has to face today. According to International Energy Agency, also known as IEA, it would take an average of $1.24 trillion a year between now and 2035 to contain the global temperature rise within 2 degrees centigrade. By 2035, the annual investment will reach $2.3 trillion, which is 6 times more the investment we are making today. IEA also indicates that in 2012, 23% of the global carbon dioxide emission from fuel combustion is from transportation. However, compared to other major greenhouse gas emission contributors, transportation sector is less effective in dealing with this issue.
With no dedicated policy, the road travel is likely to double by 2050. The share of emission would grow considerably if the trend cannot be reversed by new technologies. To replace gasoline with alternative fuels that can largely reduce carbon footprint, European Parliament urges all countries to mandate the use of biofuels as a means to contain the emission from the transport sector. Corresponding to the 2-degree scenario in IEA's analysis, biofuels should supply 27% of all transportation fuels in 2050. The total amount would be 700 million ton oil equivalent, which is 10 times higher than the current level of use. When tracing back to fundamentals, all biofuels produced by fermentation through microbe metabolism will render CO2 emission by as much as 1/3 of carbon in the feedstock. In other words, current corn or sugarcane ethanol fermentation technologies can convert 100 grams of sugars into 45 to 48 grams of ethanol while emit 49 grams of CO2. For cellulosic biofuels, which are considered more carbon neutral than traditional ones, however, 1/3 of carbon is still in the loose as greenhouse gas in the production phase. Cellulosic ethanol does not change the basic of this process. It only changes the origin of sugar from edible agriculture products to their residues. The process also reduces the biomass yields and jacks up the feedstock requirements, its associated cost, and environment impact.
Everyone considers ethanol fermentation a very mature technology and CO2 emission during fermentation a hard fact. However, a fermentation technology with no CO2 emission will immediately increase the yield from 67 to 100%, feedstock utilization, and extra CO2 reduction close in weight to the bio-butanol used. Then there would be a huge gain in biomass utilization and fundamentally a different biofuel industry.
So this is what ButyFix is coming for. Back in 2011, a research team of Industrial Technology Research Institute, as known as ITRI in Taiwan, developed a technology called ButyFix. It utilized found microorganisms which could metabolize carbohydrate, CO2, and hydrogen to effectively produce butyric acid, which is an intermediate to butanol. Butanol is a 4-carbon alcohol with more desirable fuel properties. The lab findings showed there was very little CO2 emission during the whole fermentation process, and the carbon yield from sugar could reach 94% in the lab, much higher than the 2/3 theoretical limit in conventional fermentation.
After a few years' effort, the original team had spun off from ITRI with the ButyFix technology to establish Green Cellulosity Corporation, also known as GCC, in 2014. So, how is ButyFix different from other biofuels?
Basically, ButyFix bio-butanol production process consists of 3 steps. First, cellulose and hemicellulose are converted into sugars by an eco-solvent hydrolysis process. Then sugars are converted into butyric acid in a fermentation procedure. Finally, butyric acid is chemically reduced to butanol through esterification, then hydrogenation. It has been demonstrated in the lab a fermenter with ButyFix technology can reach carbon use of more than 85% constantly with a continuous operation period of over 500 days. After successfully operating ButyFix with a 200-liter fermenter in the lab, a pilot plant with 5,000-liter fermenter was also tested to demonstrate the possibility to scale up of this technology. The result was encouraging that the carbon yield was measured at 85% before any optimization was made. A mechanism is proposed to explain the extraordinary performance of ButyFix technology. It is believed that GCC's proprietary microorganisms used in sugar fermentation for the production of butyric acid have the ability to reuse carbon dioxide and hydrogen generated during the fermentation process to convert more biomass into products in situ, and as the consequence, lower the carbon dioxide emission. This mechanism of good carbon fixation delivered by this microorganism is the key to the success of ButyFix. The project team is continuously working to decipher all the underlying mechanistic details of the system. In addition to convert it to a biofuel, butyric acid itself is also an important chemical which has multiple applications, such as precursor for anti-cancer products in pharmaceutical, and as one of the starting material for the manufacture of biodegradable plastics, cellulose acetate butyrate in chemical industry. Furthermore, many butyric acid esters such as methylbutyrate, acylbutyrate, and geraniolbutyrate have pleasant and fruity odor, are used as fragrance and flavoring agents in cosmetic and food industries.
As all biologic processes, scaling up also poses challenges when one inevitably has less control over the working environment during large-scale biomass handling. Once GCC resolves the issue of scaling up, bio-butanol can be a drop-in fuel easier to distribute than ethanol. In summary, climate change is a grand challenge we have to face today. It would take huge investment to contain the problem, and transport sector needs an even greater effort than others.
ButyFix offers a game-change fermentation pathway for cellulosic biofuel production. By fixing as much carbon as we can in the fermentation process, GCC can use the same amount of feedstock to produce 30% more biofuel with better gasoline compatibility than ethanol, and enable a change in the ecosystem of the biofuel production and distribution.
To produce cheaper and greener fuel for a low-carbon future, we believe ButyFix will be an effective solution.
Put butanol in the tank. We are here to invent.